Cartesian coordinate, that is for x equation of motion, for y equation of motion, and for z equation of motion. Similarly, we can write it for cylindrical coordinate system also and for spherical coordinate system also. That is further, then we can apply here also Newton's law of viscosity, and we can generalize the terms, and we can write as Navier-Stokes of equation. That is Navier-Stokes equation in Cartesian coordinate, that is density into del Vx upon del t plus Vx into del Vx upon del x plus Vy into del Vx upon del y plus Vz into del Vx upon del z. That is the left hand side term. Similarly, we can write for right hand side term, that is minus del p upon del x plus mu into del square Vx upon del x square plus del square Vx upon del y square plus del square Vx upon del z square plus rho gx, that is the forces acting in x direction, that is we are considering the x equation of motion. Similarly, we can write y equation of motion and z equation of motion. Y equation of motion, del density into del Vy upon del t plus Vx into del Vy upon del x plus Vy into del Vy upon del y plus Vz into del Vy upon del z. That is the left hand side term. We can write the right hand side term, that is del py upon del p upon del y plus mu into del square Vy upon del x square plus del square Vy upon del y square plus del square Vy upon del z square. Actually, we are taking Vy as a velocity because we are considering y equation of motion plus rho gy. That is the gravitational force acting in y equation, acting in y direction, means we are taking with respect to y direction, that is the y equation of motion. Now we can write for z equation of motion, that is density into del Vz upon del t plus Vx into del Vz upon del x plus Vy into del Vz upon del y plus Vz into del Vz upon del z. That is the left hand side term. Similarly, we can write the right hand side term, that is del p upon del z plus mu into del square Vz upon del x square plus del square Vz upon del y square plus del square Vz upon del z square plus rho gz. That is the z equation of motion. Similarly, we can derive for cylindrical coordinate, that is Navier-Stokes equation for cylindrical coordinate. Similarly, we can apply the Newton-Navier-Stokes of equation for cylindrical coordinate systems and Navier-Stokes of equation for spherical coordinate system. So first we are going to write the Navier-Stokes equation for cylindrical coordinate system, that is density into del Vr upon del t plus Vr into del Vr upon del r. As we are considering the r equation of motion, that's why velocity terms with respect to r, plus v theta upon r into del Vr upon del theta plus Vz into del Vr upon del z minus v square theta upon r, that is the left hand side term, is equals to minus of del p upon del r plus mu into whole bracket, that is del by del r into 1 upon r into del by del r into rho into r into Vr plus 1 upon r square into del square Vr upon del square theta plus del square Vr upon del square z minus 2 upon r square into del v theta upon del theta plus rho gr, that is the r equation of motion. Similarly, we can write for theta equation of motion and z equation of motion. First, we are going to write for theta equation of motion, that is density into del v theta upon del t plus Vr into del v theta upon del r plus v theta upon r into del v theta upon del theta plus Vz into del v theta upon del z plus Vr into v theta upon r, that is the left hand side term. Similarly, we can write the right hand side term, that is minus 1 upon r into del p upon del theta plus mu into 1 del into whole bracket del upon del r into 1 upon r del upon del r into r v theta plus 1 upon r square del square v theta upon del theta square plus del square v theta upon del z square plus 2 upon r square into del v r upon del theta plus rho into g into theta. Actually, rho is the density and g theta is the acceleration due to gravity, that is in theta direction with respect to theta, as we are considering now the theta equation of motion. That is the theta equation of motion. Similarly, we can write the z equation of motion, that is density into del vz upon del t plus vr into del vz upon del r plus v theta upon r into del vz upon del theta plus vz into del vz upon del z. That is the left hand side term. Similarly, we can prove it for spherical coordinate system, and here our Cartesian coordinates change to r, theta and phi. For z equation of motion, now we are going to write the RHS term, that is right hand side term, that is minus del p upon del z plus mu into 1 upon r into del by del r into r into del vz upon del r plus 1 upon r square into del square vz upon del square del theta square plus del square vz upon del z square plus rho gz, that is gz is the acceleration due to gravity, that is in z equation of motion. And now we are going to write the Navier-Stokes equation for spherical coordinate system, that is we are considering here r, theta and phi equation of motion. As we can derive the all equation, but it is quite complex and quite difficult terms we come across while deriving the above terms, that is for spherical coordinates and for cylindrical coordinates. Now we are going to write the Navier-Stokes equation for spherical coordinate, and first we will write for that for r equation of motion, that is density into del Vr upon del t plus Vr into del Vr upon del r plus V theta upon r into V phi upon r sin theta into del Vr upon del phi, that is the left hand side term. Then we can write the right hand side term, minus of V square theta minus V square phi upon r is equals to del P upon del r plus mu into 1 upon, that is the right hand side term, that is plus mu into whole bracket 1 upon r square into del square upon del r square into r square into Vr plus 1 upon r square sin theta to del by del theta plus bracket sin theta into del Vr upon del theta plus 1 upon r square sin square theta plus del square Vr upon del square phi plus rho gr, that is the r equation of motion. Similarly, we can write for theta equation of motion, that is density into del V theta upon del t plus Vr into del V theta upon del r plus V theta upon r into del V theta upon del theta plus V phi into r sin theta into del V theta upon del phi. Plus, actually these terms are so complex to derive, that's why we derived here only the equation of motion for Cartesian coordinates, that is x, y and z direction, is equals to, now we write the right hand side term, that is minus 1 upon r into del p upon del theta plus mu into 1 upon r square into del by del r into r square del V theta upon del r plus 1 upon r square into del by del theta into 1 upon sin theta into del by del 1 upon sin theta into del by del theta plus V theta into sin theta plus 1 upon r square r sin square theta into del square V theta upon del phi square plus 2 upon r square into del Vr upon del theta minus of 2 into cot theta upon r square sin theta into del v phi upon del r phi plus rho g theta, that is the theta equation of motion, that is the forces, pressure forces or forces acting in theta equation of motion. G theta is the acceleration due to gravity. Then we can write the Navier stroke equation of spherical coordinates in phi equation of motion, that is density into del v phi upon del t plus Vr into del v phi upon del r plus v phi upon r into del v phi upon del theta plus v phi upon r sin theta into del v theta upon del phi plus v theta into Vr plus v phi into cot theta, v theta into v phi into cot theta whole divided by r, that is our left hand side term. Now similarly we can write the right hand side term, that is 1 upon r sin theta into del p upon del phi, as we are considering the phi equation of motion, plus mu into whole bracket 1 upon r square del upon del r into r square del v phi upon del r plus 1 upon r square del upon del theta into 1 upon sin theta del by del theta of v of phi into sin theta plus 1 upon r square sin square theta plus del into del v square v phi upon del phi square plus 2 into 2 upon r square sin theta into del vr upon del phi plus 2 into cot theta upon r square sin theta into del v theta upon del phi bracket close plus rho g into phi, plus that is the forces acting in phi direction. We are considering it with respect to phi, as we are taking phi equation